So let's go ahead and get into kind of the introduction to these different flavors of smart pointers, if you will. The first that we're going to introduce is going to be a unique pointer that is going to be used for exclusive ownership resource management. So this pointer is going to exclusively own some sort of dynamically allocated object, and it will be the sole owner of it. So what that means is this type is going to have some sort of variable that is going to be a pointer to some sort of dynamically allocated object. Let's go with the integers because that's what we've been doing. So we might see something here like standard library unique pointer of int. We'll just call it PTR, and we'll go ahead and initialize it with make unique int. We'll go ahead and say 7. We'll get into what this is doing here later, but kind of this modern C++ is really looking to get away from seeing calls to, say, the new operator within your program. If we're using smart pointers, if we're using the unique pointer, we'll go ahead and initialize those objects using this make unique command, this make function. And when we get into the shared pointer, we'll see there's also a make shared command as well. But once we've done this, we've kind of set up this relationship. So how can we ensure, or how does this happen? Well, notice here that this constructor is going to essentially grab the resource. And we kind of introduced this, I believe, in a TRA, right? So we're going to acquire the resource in the constructor. And then when pointer PTR goes out of scope, we'll go ahead and release the resource in the destructor. Now the next question is, well, how do we make this a unique pointer? What is preventing us from doing something like this? Let me write it out real quick. So what is this? What is preventing us from doing something like creating a new unique pointer PTR 2 and initializing it with PTR? So you might be thinking here, well, we can make like a shallow copy of that address, have two things pointing to the same object. No, the reason why we're not going to be able to do this, and maybe I should have kept that and crossed it out, but the reason why we're not going to be able to essentially have multiple unique pointers pointing to the same object is going to be because copy semantics are disabled. Meaning there's no copy constructor, there's no copy assignment operator, which means once this object latches onto that resource, there's going to be no ability to create some sort of instance with two unique pointers where that resource is being shared. So then the next question becomes, well, what if we need to move this resource to another unique pointer? For instance, what if we want PTR to be pointing to something else or acquire a new object? Well, to do that is going to be with move semantics, which will allow us to transfer ownership of the dynamically allocated object to another one, which is pretty cool because this unique pointer, it's going to be the whole mantra is exclusive ownership of some sort of resource, meaning that, okay, we're not going to be able to have multiple things pointing to it. The unique pointer is not going to allow that functionality, so we won't have any sort of copy semantics that would allow, say, another unique pointer to come in and point to that object on the free store storing the integer value of 7. However, we would be able to go ahead and transfer that object to some other unique pointer. And there's a variety of kind of different scenarios where we might need to do a transfer of ownership if maybe we're I don't know, if we're using unique pointers to implement a linked list, well, what if we want to kind of absorb a new node somewhere in the middle or tag on a maybe new node at the end? Well, if we need to update our pointers, we're going to need some sort of ownership transfer to make that happen.